Hello guys, my name is Balkrishna Srivastava and welcome to Code with BK. So in this video we write C++ code solution for LeetCode Problem number 94, binary tree inorder traversal. So before we begin, it is a request to please subscribe to my channel. So take a minute and give this question a reading. Alright, so you are given a binary tree and you have to find the in order traversal of this binary tree, and it's a very standard thing. So we have in order, post order, pre-order traversals. We have to cover in order traversal in this case. So I'm going to write the code first, test this, and then I'm going to explain how this works. Okay, so traversing the tree in order means visit the left subtree, visit the root, and visit the right subtree, and this goes recursively. Alright, for example, if you're visiting the subtree, then the same idea. It's left subtree, root, and the right subtree. Okay, so I'm going to write a function void in order traversal helper. Okay, takes a vector in which I need to populate, I'll say order, and also takes the current node. Okay, so if basically node is null, okay, you can return. All right, or you can say if not node, something like this. Else if this node is not null, we follow the order left subtree, root, right subtree. So visit left subtree. So I'm going to call the same method pass order and pass node dot left. Okay, do we have a get left? No, this is a struct, so this is going to be okay. Then visit root, which is basically visiting this node, and then visit right subtree. Okay, so you say the same function, you pass the right subtree. Okay, and visiting this root means you're adding the current root value node dot val to this order. Okay, so all you have to do in this function is take a vector. Okay, I'll say order, call this helper function, pass order and root, and return order. Okay, this should be your code. Okay, submitting this. Okay, all right, very minimal code, works on recursion. Now I'll try to explain using this second tree diagram on what we are trying to do. So our idea is to in order we visit left subtree, root, and then right subtree, and it goes for the entire tree. We have to follow this order. So in order for this tree is going to be generated. How? We start with this root. Okay, so we have to visit the left subtree of this root, then visit this root, and then the right subtree. Okay, since left subtree is also a tree, we follow the same idea because this goes recursively. If you look at the code, okay, you have to visit the left subtree, which is basically calling the same function, and you have to visit its left subtree. Okay, so this red color is your first call. Let me change color, I'll make it to this orange. Okay, so when you are visiting this as the root, now this is the node that you get here. Okay, so you have to visit left subtree, then root, then right subtree. Okay, then you visit this. Now since this left subtree, this 4 is just one node, so 4 is the first element that is added. So 4 is the first element that is added. Okay, now you have visited this left subtree, you visit root, which is 2, so you have 2 as the next element in our in order, and then you have to visit the right subtree. Now when you visit this right subtree, it has to follow the same order. Okay, left subtree, root, right subtree. So 6, then 5, then 7. So 6, 5, 7. Okay, so in this left subtree, you visited this left subtree, this root, and this right subtree. So this entire left subtree for this root is not visited. Then you visit root, which is 1, and then you visit this right subtree. Okay, following the same order. Now this is your root, which is passed as node here, this function. Okay, so you have to visit its left subtree, which is not there, nothing here. So you visit root, which is 3. Okay, and then you visit the right subtree, which is this part. Again, following the same idea, okay, left subtree, which is not there, then root, then right subtree. So 8 and 9. So 8 and 9. Okay, and now you have visited this entire right subtree. So when you started with root, you visited your left subtree, your root, and the right subtree. So this is your in-order traversal. 42657 42657 398 398, which is what we want. Okay, so this is your in-order traversal in a binary tree in C++. The algorithm remains the same. Okay, you just have to update the code. If you're using C, C++ or Python, Java or Python, the algorithm remains the same because binary trees are data structure that you can use in other languages as well. Okay, so I hope this video was helpful and you like this video. If there is any doubt, there's a part you don't understand, please let me know in the comments. I always try to answer all your comments, and you can always let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.